Sıradaki konuşmacımız Cooltech Solution ve DCX'ten Maciek Szadkowski. Kendisini alkışlarınızla sahneye davet ediyorum.
Thank you so much. So yes, I will try to. My name is Maciek, and I will try to present a couple of considerations, a couple of informations about how to deploy the liquid cooling system and how to do it safely, in the most safe way. So yes, we are working together with Cooltech and and we joined forces to prepare and to give you the best, most complex, most safe consulting and design and integration to deploy in a safe way liquid cooling systems for the data centers in Turkey. And that's our mission. We just started, but we are having pretty large progress, and I will say about that a little bit later. So DCX is actually on the market since 2016, and we are laser focused on liquid cooling technologies, liquid cooling systems. Only that we don't do anything else, and we provide, obviously we produce and we design and we deliver, we do the installation services, and we provide all the main components of the liquid cooling system, which means obviously coolant distribution units, critical component of every single liquid cooling system. We provide the design services, consulting, sizing, safety, right? And we do provide also rack level components, which are basically the manifolds and the culprits. Right? So that's what we do. But obviously we have a pretty broad range, because in terms of those coolant distribution units, we are starting from 100 kilowatts and we end up at 9 megawatt coolant distribution units for the very large hyperscalers. So, well, there's nothing which will surprise us probably at that moment. We also provide immersion cooling systems. It's very new. It's just coming to the market. It's not right now, not something what people are looking for, but there are specific use cases like edge applications when the immersion cooling is amazing. It just works. So BTS station, telecommunication services, that's where the immersion cooling systems come. So, why we need that liquid cooling systems actually, right? The energy efficiency, sustainability, the regulators, pressuring the gas to be more, energy efficient, right? That kind of, main factors, right? At least that's what we like to tell. And because in the reality we don't do the liquid cooling, because we are pressurized by everyone to provide the liquid cooling systems. And the energy efficiency was also the issue always. We have energy crisis, right? So we don't do liquid cooling because of that, actually, right? We do liquid cooling because our kids are doing the homework using ChatGPT, right? Simple as that. ChatGPT came out, AI came out, generative AI came out, and now everything exploded. Everything, put on top of its head. We will have AI augmented employees. Even right now, if we have some issues, we go to ChatGPT and we ask the quick question, and we get the engineering level answer, very detailed one, right? AI is smarter than most of us here, right? And the guy in the middle, he's running the company called Klarna. It's one of those fintechs, the payments in installments, in rates. And they just let go 2,000 people and replace them with the AI agents, because AI agents work 24/7. They know 100 languages, and they shortened the time for the ticket resolution from 12 minutes to 2 minutes, and customer satisfaction is very high, right? And yes, we have robotics, we have automation, right? You know how many robots we have right now? There's so many robots right now. They cost $16,000. The robots which you can buy. Like we were buying for home those Roomba robots, right? And we'll be buying them for home to do the dishes, whatever, rig the tea, rig the chai. So it's happening right now. It's happening right now, and we love the cars which drive themselves, right, on the highway at least. So it's happening big time, and the case is that the AI, well, it helps a lot, and obviously there are tons of those large startups which want to host the high-capacity racks. And some of those startups, which you can see here, these are our customers, right? We work mostly for hyperscalers. So if we know that the AI is here to stay, right? then what that means, technically. That's AI racks. The first one is current generation of AI GPUs. The next one is the one which is just coming. It's their first batches being produced, and they will be delivered in the middle of the year, more or less. The last one rack, that's the one which we deployed already, 200 kilowatts. And we know what's coming in the, let's say, whole data center world. Well, the next generation racks are supposed to be 600 kilowatts, 800 kilowatts, right? And I know these are AI systems, large hyperscalers. But if you're running data center business, and if you like to get that fat contract from the major hyperscaler, then you get to deliver the liquid cooling components. There's no other way, right? And eventually, well, we started from those AI racks, very, very powerful. But once you know the technology, you'll basically replace the traditional air cooling with the liquid cooling. It will proliferate to the other racks, right? It will happen eventually. Well, because I know the liquid cooling is kind of complex, right? And there are some challenges in the very beginning. And then people basically are afraid to put the water into the servers. Simple as that. Water with servers, okay, doesn't really fit. But the other problem is that we need to, you as a data center professionals, you need to assume the responsibility for the system which you don't know, right? So there are some risks, and we try to address those risks, and we try to tell you how to do it properly. So what do we mean by the direct chip cooling actually? What's direct chip cooling? So that does that mostly. Direct chip cooling means that we don't need cold water anymore for most of the load. So we can use warm water to not cool the servers, but to transport the heat away. Right? So we use the really warm water. Or it's to save a lot on the heat rejection. So we don't need adiabatic cooling. We eliminate most of the chillers. It's super efficient, that's why we do it. Right? And we can get the best viewing. And finally, what's most important, we can host AI. Because there's no way you can host AI without the liquid cooling. So these are the reasons why we actually do the liquid cooling. The only topic is, what will happen if I will get the leak? That's the magic question. So the other problem is obviously how to build it properly. And most of the customers and most of these large players like Vertiv or Schneider, they will try to convince you to build the supercomputer. Because liquid cooling was mostly associated with high performance computing, with supercomputers, scientific institutions, right? So that was the liquid cooling. And people try to then replicate that build, which was working at supercomputers, to their data centers. But it's really expensive. It's super expensive, so we don't want that. And we have the better solution, I guess, in terms of how to build it, properly. There are just four important factors, four important items which you should, think about when you plan to deploy the liquid cooling solution. First of all, choosing the right topology because it defines for the future. You put those pipes inside your data hall, inside of white space, and well, you won't replace them with the next generation of servers within 3 years, right? You want to, let's say, leave it as that, and the pipes and the diameters and the flow rates and everything must be prepared for that, expansion, for that growth, for the future. You don't want to, let's say, do it, every 3 years. So that's first. Secondly, well, we should choose the different CDUs than you are thinking right now. Most of the customers using the, let's say, outdated CDUs, which were designed before AI era, before AI happened, when the AI was machine learning and no one knew what was that actually. The third item, very important, is chemistry and maintenance schedules. I cannot stress how important it is. So that's the third one. And fourth, well, you need to find someone who will help you to design the system, and that's when we kind of fit in. The problem with the topologies is that normally you'll be convinced to use the outdated topology. So let's put those coolant distribution units, we need them, between the racks. Let's put those pumps and water reservoirs into the sacred white space, into the data hall. So it's kind of outdated design because obviously you have lots of pipes which are going in the data center, right? And you have the pipes for the secondary loop. So from the CDUs to the individual racks. You have the pipes from the heat rejection going to the CDUs. So again, another set of pipes. And you have And you need to still support rear-door heat exchangers, for example, or fan walls, or the in-row units. So another set of pipes. So there's not that much space, and the racks becoming more powerful. So we start fighting for the space with busways, bus bars, containment. Well, that's kind of challenging. So we suggest using different topology. Simple as that. And that's the new one, right? So let's build that in a different way. Let's separate mechanically power and compute, busway, bus bars, containment, everything, from the hydraulic systems. Because hydraulic systems means messy, right? Means reservoirs, adding the coolants, changing the coolants, replacing the filters, eventually replacing the pump motors. So you don't want to do that on the white space. So ideally, let's put those, the rows can be shorter or longer, that doesn't matter. But let's put the loops let's put all those CDUs, all that messy part, all those pumps in the separate room. It could be technical corridor, right? And, or basically custom rooms, made only for the hydraulic systems. And those systems will pick up 85% of the heat load which you have. And you would be just left with 15 or 20% maximum of the heat load which you need to account, which you need to ventilate, or which you need the chillers for. Right. Second point, let's use different CDUs. That's a pretty big one, 5 megawatt. So it can serve whole floor. That's the second one. Choose different CDUs because the CDUs are very expensive. The lead time for the CDUs from the major players is right now 50 weeks, 40 weeks. So we are at the 20 something. So let's choose different FDUs. And the final item, there's not much to be here, but there's lots of ions, turbidity, conductivity, pH, corrosion rate, all those parameters of water. The chemistry and the right maintenance schedule is the most important part in every single direct cooling system. The most important part. As you can imagine, warm water, perfect place for growth, right? Of the bacteria, of let's say fauna or flora. So we need to add the additives, biocides, corrosion inhibitors, and different other inhibitors. So, and you need to control the cooling medium. That's water, DI water, or any mixture. So that's important. Eventually, if we compare those two types of building systems, so lots of small CDUs in between the racks, in-row units, and the centralized CDUs, which cover more racks, well, the cost there's a huge difference. And also it also accounts for all the other items, like for example, the lead times. When you want to get those racks and those manifolds and the pipes and everything, it's important to make sure that you are energy efficient, but you are also cost efficient. And that's, I guess, very, very, very important. We produce everything in Poland, Europe, so pretty close by. And as you can imagine, the labor cost in Poland is more or less similar to Turkey. So it's not, you don't have to buy US-made, very expensive CDUs. You can buy, but the cost difference is sometimes 3 times. It's not even half of the cost; it's more. So that's basically reasonable assumption that you should look elsewhere. You should not go to those large players. You should look outside of the box, right? So yes, these are those 4 very, very important considerations. Choose topology once, you will save later. Choose different CDUs, think outside of the box. Think about the long-term management, long-term maintenance of the cooling medium, right? That's important. And finally, find someone who will design for you the whole system and will take the responsibility for the design and the heat transfer effectiveness. The problem which you have, and which you might have, is that basically you have different conflicting information from the CDU manufacturer, from the cooling tower or molecular manufacturer, from the server vendor, and then you need to assume this position of taking responsibility for everything, right? And you never did liquid cooling before, right? So it's better to find someone who will take the responsibility, so it works perfectly for now and for the future. These are those 4 important considerations. As I mentioned at the beginning, we just starting. We have first proof of concepts in Turkey. First deployments, they're just on its way. They'll be delivered in a couple of weeks. So we'll have more to show. We supplied for now the systems to, I think it's 77 countries right now. Mostly to US, to Europe, to other countries in Europe. But eventually we will work tirelessly with Mr. Abbastan and the whole Cooltech team to design custom OEM solutions assembled in Turkey and being locally manufactured, assembled, and then delivered to customers and supported locally. That's most important, right? So no more of US-based, expensive systems being sold at 200% margins, right? We need to have something local, and we need to support you guys locally. So these are 4 considerations, and if we have some time, I can answer some questions which you may have. Thank you.